Good afternoon, everybody. I'm Bebeth Olivar, and I will report about ultrasonic sensor.
What is an ultrasonic sensor? As the name indicates, ultrasonic sensors measure distance by using ultrasonic waves. The sensor head emits an ultrasonic wave and receives the wave reflected from the target. Ultrasonic sensors measure the distance to the target by measuring the time between the emission and reception. The sonic in the ultrasonic refers to sound, and ultra means that humans cannot hear it, but bats and dogs can hear those sounds. It can measure distances in centimeters and inches. It can measure from 0 to 2.5 meters with a precision of 3 centimeters. It looks very well and provides good readings in sensing large-size objects with hard surfaces. The ultrasonic sensor is a transducer which converts electrical energy into sound waves and vice versa. These sound waves fall above the normal range of human hearing and hence it is known as the ultrasonic waves. This type of waves is above the frequency of 18,000 Hz. An ultrasonic sensor has two parts: the transmitter and the receiver. The first one is a transmitter that sends out signal that humans cannot hear. The transmitter part converts electrical energy into sound and transmits it, while the receiver, it receives the signals after it has bounced off nearby objects and turned these received sound waves into electrical energy. How does an ultrasonic sensor work? The sensor sends out its signal and determines how long the signal takes to come back. If the object is very close to the sensor, the signal comes back quickly. If the object is far away from the sensor, the signal takes longer to come back. If the objects are too far away from the sensor, the signal takes so long to come back or is very weak when it comes back that the receiver cannot detect it. The sensor sends a message back to the computer brick telling it the time taken for the signal to return. Then, the brick uses this information to compute how far the object is. How can we measure distance? The ultrasonic sensor sends out sound from one side and receives sound reflected from an object on the other side. The sensor uses the time it takes for the sound to come back from the object in front to determine the distance of an object. Technically, the ultrasonic sensor uses sonar to determine the distance of an object. Here's what happens. The transmitter or the trigger pin sends a signal, which is a high-frequency sound, and when this signal finds an object, it is reflected, and then the transmitter or the echo pin receives it. The time between the transmission and reception of the signal allows us to know the distance of an object. This is possible because we know the sound's velocity in the air. The HCSRO4 ultrasonic sensor. As shown in the figure, it is a 4-pin module whose pin names are VCC, trigger, echo, and ground respectively. This sensor is a very popular sensor used in many applications where measuring distance or sensing objects are required. The module has two eyes-like projects in front which forms the ultrasonic transmitter and receiver. The sensor works with a simple high school formula that distance is equal to speed times time. It is commonly used with both microcontroller and processor platforms like Arduino, ARM, PIC, Raspberry Pi, and etc. Ultrasonic sensor pin configuration. The VCC pin powers the sensor typically with 5 volts. The trigger pin is an input pin. This pin has to be kept high for 10 microseconds to initialize measurement by sending US waves. Echo or the echo pin is an output pin. This pin goes high for a period of time which will be equal to the time taken for the US wave to return back to the sensor, while the ground pin is connected to the ground of the system. Advantages of ultrasonic sensors. Their small size makes it easy to integrate into projects. Ultrasonic can easily integrate with any type of controller. Their high frequency, sensitivity, and power make it easy to detect objects. They have greater accuracy than many other methods at measuring thickness and depth of a parallel surface. Ultrasonic are easy to use and not dangerous during operation, and it is an inexpensive option. Applications. Ultrasonic sensors can be used in anti-collision detection, people detection, contouring, presence detection, box sorting using a multi-transducer system, easy control of trash collection vehicles, pallet detections with forklifts, bottle counting on drink filling machines, and liquid level sensing. Arduino with HTR04 sensor. This sensor is really cool and popular among the Arduino tinkerers, so we provide an example on how to use the HCSR04 ultrasonic sensor with Arduino. In this project, the ultrasonic sensor detects distance of an object using an LED light. The goal of this project is to help you understand how the sensor works. Then, you can use this example in your own projects.
Hello guys! Today, we will connect an HCSR04 ultrasonic sensor to an Arduino to see how the ultrasonic sensor detects an object using the LED light as an output. For the materials that we are going to need, the first one is the HCSR04 ultrasonic sensor. The next one is the Arduino Mega or Arduino Uno. We also need jumper wires for the connection, breadboard, and especially the LED light. So for the connections, we will just follow the schematic diagram that I got from the internet. So, are you ready? Let's connect! And now we're done connecting the schematic diagram. So we will now test if it will work using the program encoded in the Arduino application. So, let's try it. So if the object is less than 10 centimeters away from the sensor, the LED light will light up, and if it is greater than 10 centimeters, it will die. So let's test it. Oh. So, yay! It's working. The sensor is sensing. That would be all. Thank you.